Several people in the discussion asked the question, why is kinetic energy conserved in an elastic collision? And I have several answers to that. The first answer is that that's simply the definition of what an elastic collision means. Elastic collisions, by definition, mean that kinetic energy is the same before and after. Okay, well that doesn't really give you very much insight. So let's consider two situations, a macroscopic situation and a microscopic situation. I'll start with macroscopic. Large objects, meaning objects that contain many, many atoms. In a macroscopic elastic collision, you can never have one that's really, truly, perfectly elastic. This is always going to be kind of an approximation. That approximation works pretty well when you have objects that are very hard or stiff, like billiard balls. They don't deform very much, or they don't make very much sound, they don't create much heat when they collide. Or if you have objects that are very springy, they return to their original shape very easily, and they do it without making a lot of sound or making a lot of heat. What we're really kind of saying in these situations is that whatever kinetic energy might be turned into heat or sound is negligible compared to the total kinetic energy involved in the situation. Because in the macroscopic world, in daily life, things are never perfect. But if you have a negligible amount of energy getting turned into heat and sound, then you can say kinetic energy is more or less conserved. Now, on a microscopic level, kinetic energy often, usually, is exactly conserved before and after a collision or an interaction. That's because typically we're dealing with collisions between a pair of subatomic particles, and in these collision processes, first of all, they're not contact forces, they're field forces. There isn't really such a thing as contact force at a microscopic level. And so the particles, the pair of particles are only interacting with one another, and there's nothing else for them to hit or influence to turn some of their kinetic energy into heat or sound. It does happen sometimes in microscopic interactions that you get some light emitted, but that's a kind of a separate topic that we're going to save for Physics 7. In microscopic particle interactions, it's almost always the case that they are truly, really elastic and kinetic energy is conserved.